Hello and welcome to another Orange Coast College mathematics video. In this video, we want to review properties of exponents and using properties of exponents to simplify exponential expressions that have rational exponents. So before we begin, let's just sort of look at some basic properties of exponential expressions. So if we multiply two exponential expressions, x to the a times x to the b, then if they have the same base, then we can simplify this by simply adding the exponents together. And similarly, if we divide, we simplify by subtracting the exponents, right? So x to the a over x to the b is x to the a minus b. If we have an exponential expression here, it's like x to the a, and we raise it to the b power, then we simplify this by taking x to the a times b power. We could also write this, instead of writing it as x to the a raised to the b, that is the same as x to the b raised to the a. Okay? And finally, if we have a product being raised to a power, we simply raise each factor to that same power. So if you have x times y to the a, you can raise x to the a and y to the a. Example 1, simplify this. So we have c to the 1/2 power times c to the 3/4 power. So using the rule we had on the last slide here, this is just going to be c to the 1/2 plus 3/4 power. Now, to add those two fractions, 1/2 plus 3/4, we need to find the least common denominator. The least common denominator between 2 and 4 is 4. So we can simply multiply 1/2 by 2 over 2, and that will give us c to the 2/4 plus 3/4, and that gives us our final answer of c to the 5/4 power. All right, example 2. All right, we want to simplify this expression here. So we do this, since we raise x to the 6/5 powers, that's being raised to the 10/9 power, we can just take this as x to the 6/5 times 10/9. And so the only thing that remains is to multiply those two fractions and simplify. So you'll notice here 10, we have a 10 in the numerator and a 5 in the denominator, so we can of course simplify that. That'll be simplified to 1, so 2 over 1. And then 6 in the numerator, 9 in the denominator. Both of those have a common factor of 3. So if we factor that out, we will get 2 and then a 3 here, right? And so we end up getting here is x to the 2 times 2 is 4, divided by 1 times 3 is 3. Example 3. All right, we have multiple factors inside the parentheses, and we're raising that all to the 2/3 power. So what we'd like to do is we'd like to raise each factor to the 2/3 power separately. Now, before we do that, it can be helpful when we have parentheses to check, is there any simplification we can do within the parentheses? In this case, there's not, but it can be helpful to simplify within the parentheses first before applying this exponent to each factor. All right. However, there is no simplification inside the parentheses here. So we have 8 to the 2/3 power. We'll have a to the 15 over 4 to the 2/3 power. And then b to the 9/8, and again to the 2/3 power. And now we simplify this. So you can write 8 to the 2/3. We have a numerical factor here. So what you could do here is you could think about 8 as being the cube root of 2. And so what you could do is you could write this as 8 to the 1/3 power squared. Okay. And then over here, we'll have 8 to the 15 over 4 times 2/3. And then b to the 9/8 times 2/3. All right. 8 to the 1/3 power, right? That's just 2, because 8 is the cube, 8 is 2 cubed. So 2 cubed to the 1/3 will cancel out, giving us 2. So we get 2 squared. And then for a, the a factor, 15 and 3 have a common factor of 3. So if we cancel that out, we'll get a 5 here and a 1 down here. And then 2 and 4 have a common factor of 2. If we cancel that out, we get 1 here and 2 there. So that will leave us with 5 times 1 over 2. So 5 halves. And then for b, 9 and 3 have a common factor of 3. And 2 and 8 have a common factor of 2. So that leaves us like this. So we end up with b to the 3/4 power. We're almost done. we end up with 4a to the 5/2 b to the 3/4. Last example. As we mentioned in the previous example, we have multiple factors within the parentheses here. So we could apply this 1/2, this exponent, to each factor within the parentheses, but I think it will be easier if we simplify what we have in here first. So we can use the sort of division property when we're dividing exponential expressions. And what we get here is 4/9. We have a 4 in the numerator and a 9 in the denominator. Those cannot be simplified. But we have x to the 5/3 in the numerator and x to the 1/3 in the denominator. So if we subtract that, we'll have 5/3 minus 1/3 will give us 4/3. And here, y to the 1/5 and y to the 3/5, that will be 1/5 minus 3/5 will give us y to the negative 2/5. Okay. The last thing I want to do here is normally we will not write y to the negative 2/5 in the numerator. What we'll do is we will move that into the denominator. So we end up with 4x to the 4/3 divided by 9y to the 2/5. And then that's to the 1/2 power. Okay, so now apply that 1/2 power to every factor inside the parentheses. So we have 4 to the 1/2 power, x to the 4/3, so it'll be x to the 4/3 times 1/2 power. And then in the denominator, it'll be 9 to the 1/2 times y to the 2/5 times 1/2. Okay, now the 4 to the 1/2 power, the 1/2 power is the same as the square root. So it's the square root of 4 is 2. And then when we handle the x factor here, we have a common factor of 4, and 2 and 4 have a common factor of 2. So if we cancel that out, it leaves us with a 2 here and a 1 here. So what we have here is x to the 2/3 power. And then in the denominator, the square root of 9 is 3. And we have a common factor of 2 here and here. So we cancel those out, leaves us with a 1. And we have y to the 1/5 power. And that's it for using properties of exponents. So practice this a bunch. It can be a little tricky, especially problems like this final example. But practice and you'll have it down in no time. All right. Until next time, have fun.